In this video, let us see how to perform a push operation on a stack. This is quite analogous to how we add a new chair on a stack of chairs. We always add a new chair on top of it. So what is a push operation on a stack in terms of computer science? Well, a push operation adds an element to a stack. And as described in the earlier lectures, elements are always added on top of the stack. So you have only one end and all the elements go from that end inside the stack. The notation to use this push operation is quite simple. You just have to say push and give the number to be pushed onto the stack. Let us now see an implementation scenario for a stack. So I have this visualization tool that I've created to explain the working of a stack. So stack can be implemented as an array, and you all know what's an array. It's basically a collection of elements which can be accessed randomly. Now how do we limit this access to just the top of the stack? How do we implement the constraint that is defined in the stack abstract data type, which is that only one end of the stack is open? So basically we declare an array of some specific size. Let us say in this case we have declared an array of 10 elements. Now in order to keep track of the top of the stack, you need to have something that points to the top of the stack. So in this case we are initializing a variable known as top, which contains the value to which the top of the stack points. In this case the stack is not initialized, so we are pointing the top of the stack to -1. You'll soon understand why this is -1. Let us try and push some elements onto the stack. So I'll push the number 23 and click the push button. As you can see, it showed you all the operations that it performed. So consider the operation this way. You have only the top as a means to access the stack. So here the top pointer is pointing to the top of stack. Right now the stack contains only one element, so it is pointing to that element. Once we insert a new element, it points to that element. So for example, if you have to insert some number, let's say 12, so this number 12 has to go in this place, A1. So for this, you need to increment the top to point to 1, and then using that pointer, you put the value into that space. So it's pretty simple. So first, increment the top of stack, and then store the value to the top. Again, a recap. Let's push number 45, increment the top, and then put the value onto the top. Quite simple, right? Now let us suppose that you go on adding elements to the stack, and because arrays in many programming languages are of limited size, you can reach the end of the stack. That means there is no more space to add new elements. In this case, we say that there is a stack overflow. So let us go back to our visualization and let me add a few elements for you. So I have added a few elements. Let us add the last element to the stack. Let's add 45. Next, if I try to put, let's say 56 onto the top of stack, it will say that there is a stack overflow because there is no more space to store a new element. So that is why we call it a stack overflow. So that was how you perform a push operation on a stack. Next, we are going to check how do we perform the pop operation. I would suggest you to try to implement the stack push operation in C language.